In this video, we'll talk about multiplying rational expressions and then dividing rational expressions. So we'll talk about multiplying rational expressions first. Now let me remind you of how you were first taught about how to multiply rational expressions. Or maybe this probably, because I wasn't in elementary school with you, I don't really know, but I'm going to guess. Whenever you multiply fractions together, you multiply the numerator times the numerator and the denominator times the denominator, get your answer, you simplify, and you go. So 14 times 10 is 140. 4 times 7 is 28. Then I would simplify 140 over 28. And I'm cheating because I'm using my calculator. Well, that simplifies to 5. Now, cool, that works great for numbers, but if you think about me having to do this for algebra, having to multiply 2x minus 4 times the trinomial, then multiply the second trinomial times 6x, then I'm going to get a bunch of algebra over even more algebra, and then having to simplify. It seems like a lot of work that honestly I don't want to do. So if I can make this expression at the end a little bit simpler, let's do that. So here's another way to multiply rational expressions that will be more manageable when it comes time to having to do with algebra. All right, instead of multiplying first, another way you can multiply fractions is if you simplify first. By simplify, I mean like simplify the whole problem. So I'm going to factor 14 over 4 to be 7 times 2, because 7 times 2 is the same as 14, over 2 times 2, times 10. I'm going to factor that to 5 times 2, and 7 is prime, so I'm going to leave it as 7. Now, you can if you factor everything, you can simplify one term in the numerator with one term in the denominator. So I see how I see a 7 right here. I can go ahead and divide that with the 7 over there, as long as one is in the numerator and one is in the denominator. You can divide out one on the top for one on the bottom. So then let me just get a different color to differentiate these things. All right, so then this 2, I can divide out with a 2 in the denominator, but only one of them. And then I have another 2 in the numerator that I can divide out with the other 2 in the denominator. So pretty much everything kind of cancels out, and all I'm left with is a 5 in the numerator. Nothing is left in the denominator. It's all been divided out, so I can put a 1 there, and 5 divided by 1 is just 5. And see, I could do all of that without even touching my calculator. That's the approach that we're going to want to use. So here are the steps. Number 1, you're going to factor everything as much as possible. Does that sound familiar from simplifying? Number 2, then we're going to divide out any common factors. Once you've factored and divided, your third step, that's where the multiplying comes into play. You'll multiply straight across. Okay, so here's an example. Perform the following operation and express in simplest form. So I'm going to factor everything as much as possible. So right here, 2x plus 14, there's a greatest common factor of 2. So I can factor that into 2 times x plus 7. That part's factored. Bring down my division symbol. Then I'm going to factor this denominator. It's a trinomial, so I'll set up 2 sets of parentheses. To get x squared, I can multiply x times x. To get 56, I can multiply 7 times 8, and if they're both positive, 7x plus 8x will combine to be 15. Then I'll bring down my multiplication symbol and my other fraction bar. Okay, then right here I'll factor this part. See, x times x is x squared. To get 40, let's see, factors of 40, 1 times 40, 2 times 20, 3, 4 times 10, 5 times 8. There we go, because I need to combine and get 3. So I'll do a 5 and an 8 with a positive 8 and a negative 5, because negative 5x plus 8x will give me positive 3x. Then the 6x, not much I can think about factoring, but I can say that 6 is the same as 2 times 3 and have that x there. Okay, let me delete these factors here. Get those out of the way. Okay, equals. Now I'm going to start looking for common factors. Where's my... Let's see, common factor that I can divide out. Let's see, do I see? There's a 2. I can divide it out with that 2. So the 2's are gone. X plus 7 divides out with this x plus 7. X plus 8, this is getting exciting, divided by x plus 8. Okay, there's no x minus 5s anywhere. There's no 3x's. So that means this is just totally simplified to x minus 5 over 3x. That's multiplying. Now, let's talk about dividing. Now, dividing is very similar to multiplication, except you have to be a little bit careful, because if I take, let's say I had 2/3 and I wanted to divide it by 7/3. The way that you divide fractions is you have to multiply the first fraction by the reciprocal of the second fraction. Now, reciprocal means that you flip it. So the way I would divide 2/3 by 7/3, I would say this is the same as 2/3. Keep the first fraction the same. Change the division symbol to multiplication. Flip the second fraction. So you might have been taught keep, change, flip. Keep, change, flip. Then I'm going to go ahead and say, are there any common factors I can divide out? The 3's. So this ends up just being 2/7. All right, now let's do this with algebra. All right, x squared minus 16. Again, we're going to factor everything as much as we can. So x squared minus 16 will factor into x plus 4 times x minus 4, because that's a difference of squares. The denominator's got 2 terms, but I see a greatest common factor of 2 in both of the terms. So I'll factor out a 2 times x minus 9. I'm going to bring over my division symbol. I'll flip in a minute. Let's factor first. X squared minus 2x minus 8. To get x squared, I can multiply x times x. To get 8, if I do 4 and 2, make the 4 negative and the 2 positive, then negative 4x plus 2x will combine to be negative 2x. And then x plus 2 really doesn't do anything. Okay, so now I'm going to change this. So I'm going to keep the first fraction. I'm going to multiply it by the reciprocal of the second fraction. So I'm just carrying the first fraction down. Now I'm going to multiply it by the reciprocal, so the x minus 4 and x plus 2's go on the denominator, and then x plus 2 in the numerator. All right, so now I've changed it to a multiplication problem. It's time to look for common factors. X plus 2 has a common factor with x plus 2. There's an x minus 4 and another x minus 4. I don't see anything else. So it looks like this totally simplifies to x plus 4 over 2 times x minus 9. And that is how you divide rational expressions.